Yeah, hi. I'm Dr. Surikaran Chebrolu, working in CSC department at KL University. Today, the topic will be on Chomsky hierarchy, which is from the subject automata theory and formal languages. Now, the aim of this particular session is to understand the Chomsky hierarchy in a better way. Now, the main instructional objectives will be the Chomsky hierarchy and its levels of formal languages will be discussed here, and the characteristics as well. Now, the learning outcomes will be the Chomsky hierarchy do have certain levels, right? Each level I will be trying to explain which are of type 0, type 1 and everything. And we need to explain with the help of the examples. Now, what actually is Chomsky hierarchy? The term hierarchy itself says that we are talking something related to certain levels. So, what are those types of levels and what are all these things? First of all, I would like to say the introduction part of the Chomsky hierarchy. According to Chomsky hierarchy, the grammars are divided into 4 different categories. Among them, type 0 is known as unrestricted grammar. And what is this unrestricted grammar and everything will be learning in coming slides. And the next grammar will be type 1 grammar, which is known as context sensitive grammar. And the next type is known as context free grammar, which is of type 2. And the last one is regular grammar, which comes under type 3. Now, let me start with a simple table. With the table, we will be learning what actually this particular language is. Now, among the given grammar, the first one is type 0, where the grammar that we use is unrestricted grammar, and the language that it is accepted by, we call it as recursively enumerable language. And finally, the automaton that we use for representing type 0 grammar is Turing machine. And next comes the type 1 grammar, in which we use context sensitive grammar, and the language that is accepted, we call it as context sensitive language, and the automaton that we use, we call it as linear bounded automaton. And the next one, type 2 grammar. Here we make use of a grammar called as context free grammar, and the language that we implement, we call it as context free language, and the automaton that we use here is PDA. The full form is push down automata. And the last one is type 3, which we use a regular grammar, and the language that we use here, we call it as regular language, and the automaton that we use for representing this one is finite state automaton. Now, coming to the top, what do you mean by this particular grammar? And let us learn regarding the characteristics of the grammar. And the first one, we call it as regular grammar. It is of, the predictions will be of A tends to XB or A, or else A tends to BX or A, right? Here we divide this one into left side and the right side. In the left side, you need to have at most one variable, and on the right side you need to have minimum of one variable and combination of any number of terminals. And the next one is context free grammar. It is also divided into left hand side and right hand side. The left hand side we give with alpha symbol, and the right hand side we give with a beta symbol. Now, in the left hand side, alpha is given with a variable, where beta can be a string of variables or terminals, right? It can be combination of variables or terminals. This comes under context free grammar. And the next one, we call it as context sensitive grammar. Here also it is allotted with the left side as alpha and the right side as beta. And here you need to make sure that either it can be alpha or it can be beta. It is a combination of variables and terminals, right? It can have individually variables, it can have individually terminals. So we can say that the combination of variables and terminals. And there is one rule in context sensitive grammar, that the number of elements in alpha must be less than or equal to that of beta. So you need to make sure that always the left hand side must be less than the count of the right hand side, or else it can be of equal. And next, the last one is unrestricted grammar. In unrestricted grammar, it also contains two parts, on the left hand side and the right hand side, and all the rules that apply for context sensitive grammar also applies here, and only one particular rule that we need to know is on the left hand side it must not have anything like epsilon, I mean null. It must not have null there. Now, so what actually is a regular grammar? So the language that is accepted by the finite automata are called as regular language. Now there are two types of regular grammars here. One we call it as right linear grammar, and the next one we call it as a left linear grammar. Now a regular grammar is a one which is either a right linear or a left linear. So a grammar is called as regular grammar, either it follows a right linear grammar or left linear grammar. Now let us discuss what do you mean by right linear grammar. So a particular grammar is said to be a right linear if at all on the right hand side in all the productions the variables must be at the extreme right side. See here, you can observe A tends to xb. Here in that xb you can observe x is a terminal, b is a variable. Okay, so you need to write b in the extreme right of it, so that we call it as a right linear grammar. So if at all there are no variables, you can straight away represent with a simple terminal. Even it comes under right linear grammar. So here you can see a and b belongs to variables and x belongs to terminal. Now in this example you can see a, b, s. Here a, b are terminals and s is a variable. You can see that s is placed on the extreme right side, so it comes under right linear grammar. And the next one is left linear grammar, and it is as similar as right linear grammar. In the right linear grammar all the variables are assigned to its right, whereas in left linear grammar all the variables are assigned to its left on the right hand side production. Now let us see an example. In the previous example you have seen a tends to xb, right, where b is a variable there which is on the right hand side. Now here a tends to bx, b will be on the left hand side, I mean not the left hand side, it is the left extreme position. So a tends to x, if at all there is no variable, you can straight away call it as left linear grammar. And here you can also see that a, b belongs to variables and x belongs to the terminals. And the example s tends to sbb, here s is a variable and bb stands for terminals. Now what actually is a regular grammar? In a regular grammar at most one area variable appears on the right side of any production. So if at all you call anything as a production which is of regular grammar, it must appear that one variable must be right side of any production, and the variable must consistently be either the rightmost or the leftmost of the right side of any production. Now the example will be s tends to a, so it contains a variable, and in the second example you can see a tends to ab, where b is of the right linear, and b tends to ab, a is of the left linear. So all these are the examples of the regular grammar. Now what do you mean by unrestricted grammar? The name unrestricted itself says that there are not much rules to follow. Okay, let me say with a clear definition, a grammar G of V sigma P S. V stands for variables, sigma stands for the inputs, P stands for the productions, and S stands for the state, is called unrestricted grammar if all the productions are of the following form. So what is that particular form? It must be like alpha tends to beta, left hand side alpha and right hand side beta, and where alpha must contain at least one non-terminal and alpha comma beta belongs to variables, with the help of that inputs. Now, in the unrestricted grammar, there are no conditions imposed on the productions. That's why it is named as unrestricted grammar. So, any number of variables and terminals can be on the left or right. These can occur in any order. There is no specific order that you need to follow. And there is only one particular restriction, as I have mentioned earlier: null is not allowed. That is, epsilon is not allowed as the left side of the production. That is the only rule that we need to follow here. And next, unrestricted grammar corresponds to the largest family of the languages, and any language generated by an unrestricted grammar is recursively enumerable language. Now, the automata for unrestricted grammar is a Turing machine. Now, next comes the context sensitive grammar. So, in this particular context sensitive grammar, we use all the grammar that we include in that context sensitive grammar, that is variables, sigma, productions and star symbols. Now, alpha tends to beta, and the main difference between this context sensitive grammar and the previous unrestricted grammar is, in context sensitive grammar we will be identifying the length of the left hand side and the length of the right hand side, and you need to make sure that the length of the left hand side must be less than that of the contents of the right hand side. And here alpha comma beta are the productions which belong to variables and the sigma. Thank you.